Hi all, welcome back. This is Anish from A Niche Data Lab with a new video. In today's discussion, we will talk about how data modeling is done in document databases. RDBMS and NoSQL databases are completely different in their architectures. You can choose each one of them based on your requirements, use cases, and features required. In today's discussion, we will be focusing on document databases. A JSON document is capable of handling multiple data types along with the primary ones. For example, arrays, nested objects can be part of a JSON document, unlike a normal RDBMS data model. So one-to-many relationships can take multiple shapes in a JSON document. Child entities can be referencing entities or embedded entities. This means the data which is stored in multiple tables connected with foreign keys in an RDBMS database can be stored in a single document in a NoSQL database. This is one reason why application programmers love document databases. The data model is similar to the application object they are familiar with. This also reduces the translation time between a normalized data and a denormalized application object. Because of this freedom available in JSON, a document database model with parent-child entities can be in the following ways. 1. A parent document has child entity IDs in an array, and the child entities reside in a separate document. In some cases, we might have partial info from the child embedded into the parent, but complete info being available in a separate document. Another model is that the complete child information can be embedded into the parent document. Or we can have something like an RDBMS model where child entities refer to the parent with something like a foreign key. In this video, we will take a few examples and see how data modeling can be done in JSON documents based on the use cases. The NoSQL versus SQL argument has raised a lot of myths floating around. We have tried to break a few of them in this video. Before looking at the examples, let's reiterate what drives data modeling in document databases. The most important criteria or parameter which defines the data modeling principle is the use case. How do you want the data to be accessed, changed, or deleted? The access patterns of the data determines how the data can be stored in the database. Example 1, a project management tool. Let's look at this tool in 3 different ways. One is the entities, second, the access patterns, and third, the data model. 1. The entities. A project management tool has projects, tasks, and people who work on these projects. In this case, project is the parent, task is the child, and is linked to the people. In a basic project management system, a task does not have an existence without the project. There are 3 types of users for a project management system. One is the project resources who work in a project on multiple tasks. They would want to see that project details and individual tasks on which they work on. The second type of users is the project manager. He will be less interested in the details of the task, but he will want to see the project status and the task status. The third type of user, which would constitute less than 10% of the usage, will be the account manager or the multiple projects manager. He will want to see the status of multiple projects, and he will not be interested in the details or the status of the individual tasks. The people who work in a single project on multiple tasks constitute almost more than 60% of the usage. So it is good if we are able to optimize the application and the data model for the usage of that 60% than keeping it optimized for the project manager as such. So a usual workflow is you open the project and then go to the task. There are multiple options of modeling the data in. The child entity, that's a task, being referred by the project makes sense because Before seeing a task, you will be opening a project. So a project page, when loaded, can show basic name and ID of the tasks. And when you click on each task, you can open the details of the task. Now let's consider one option, keeping the project and task as separate documents. Now for my project page, when I see the project, I should be able to see the ID and at least the name of the task. Now to show that in an RDBMS system, I will have to open the project record and have to do a join or a separate query which goes to the tasks table and get the project tasks and display them. Whereas in a document database, with this use case in mind, you can have your ID, the name of the task, and the person's name who's working on it embedded into the parent or the project document. When the specific task is clicked, application knows the ID of the task, can go to the database, get that task document, the entire set of details, and fetch it to the application. So in this specific use case, or in this specific access pattern, it makes sense to have a parent, that's a project document, with basic information plus ID of the child entity, that's the task, embedded into the project document. Now here is a comparison between how this data model looks in an RDBMS system versus in a document database. Please remember again that this is not an ultimate data model which solves all the purposes. This data model in the document database is done with use cases and access patterns as explained earlier. If the access patterns or use cases are different in your tool, the data model can change accordingly. This is only pointing to the direction or the approach to be taken when doing the data model. Let's move on to the next example, which is an ad engine log. Any website you browse, you might see ads based on your preferences, on your browsing history, etc. Every ad you see on screen is called an impression. When you click on it and make a purchase, a percentage of that purchase goes to the company which displayed the ad, that's ad engine. There are different billing models for an ad engine. Some get paid for the impressions. Some get paid how many times the user clicks on the ads. And some a percentage of the purchase that is done by clicking the ad. So to identify which impression got converted to the click and which click converted to the purchase, the information from impression has to be carried to the click, and all this information together has to be carried to the purchase. If you plan to go back to the impression record when the click is done, that is an expensive process. It is much more efficient to carry the impression data along with the click. The user clicks an advertisement, it takes the data of the impression and it populates into the click. A click is converted to a purchase. The impression data, the click data, and the purchase data are carried together to identify the conversion. This, if you plan to look back at each event, it will result in a very expensive process. In NoSQL environment, it is easy. This is not a parent-child relationship. This is a relationship between multiple entities. So the impression data will be embedded in the click record. The impression plus click record is embedded in the purchase record. Thus, the look back is avoided. The high frequency writes and high frequency reads do not need child reads or write to complete the transaction because the information is already available in those documents. This data model ensures that the performance is top-notch, avoiding the lookbacks. Again, this is not an ultimate data model which solves all the problems. This data model is done with the use cases and access patterns, which I explained earlier, into consideration. To summarize, in document databases, data modeling is a rigorous exercise to finalize a target or desired data model. Parameters like entities, users, data access patterns, and other valid parameters have to be considered and evaluated carefully before you reach a desired data model. If you enjoyed this video, please like and subscribe. And more important, stay safe.